Hello and welcome to another episode of the Rocks of Utah, where we explore a new rock layer with every episode. For a while now, I wanted to do a quick video of the Eocene Colton Formation, a formation which is surprisingly fossiliferous, but has been overshadowed by similar age rock units in northern Wyoming and even in the Paris Basin of northern France. The occurrence of specific types of fossils within unique layers of sedimentary rock is one of the most rigorously tested concepts in geology. The retelling of the history of Earth, like pages of a book, has been demonstrated by every field geologist, and it really contrasts to a concept of a jumbled or random distribution of fossils in rocks. Fossils within the rock layers tell a clear story of change over time. And reading these pages of ancient history of our planet just requires observing the fossils and recording the rocks that you find them in. And this principle of change over time, as observed in the rock record, is called the Principle of Faunal Succession. The Eocene epoch, which lasted from 55.5 million years ago to about 34 million years ago, is recent enough that we can break out and divide it into even smaller divisions or ages based on the occurrence of specific fossils. Now, if you're to look at marine fossils, the ages of the Eocene are called the Ypsian, the Litonian, the Bartian, and the Parabonian. Now, the Ypsian age was named by the Belgian geologist Henri Dumont for the Flemish city of Ypres near the French border. It's recognized by a unique set of marine fossil shells, and in particular fossil marine foraminifera that are common in Europe and in North Africa. In fact, one of the more useful index fossils of the Eocene is the giant foraminifera Nummulites, which is a coin-shaped fossil, fossils that are really common in the Eocene marine deposited rocks. And they're found in limestone blocks that were actually used to build the pyramids in ancient Egypt. However, out here in the deserts of North America, far away from the ocean, we're going to have to use a different set of fossils. Fossil mammals in particular, very small mammals, are extremely useful in delimiting the ages of the Cenozoic rocks that are deposited far away from the oceans. And here in Utah, the earliest age of the Eocene is called the Wasachian age, or land mammal age, and it's slightly shorter in duration of time than compared to the Ypsian. Now, the Wasachian ended around 50 million years ago, and it was followed by the Bergerian, then Uintah, then Duchanian ages. The Wasachian is actually named after the Wasatch Mountains that divide Utah, and the Colton Formation is actually often mapped and even called the Wasatch Formation until rather recently here in Utah. Now, during the Great American Geological Surveys conducted after the Civil War in the 1870s, basically any Cenozoic rock layer that had kind of a reddish or pinkish whitish color to it was mapped as Wasatch Formation. Now, since the 1880s, however, the Wasatch Formation has been slowly being separated into different names corresponding to each of the different depositional basins in which these sediments were deposited within. Now, in Utah, the term Colton Formation was established for the type section found in Colton, Utah, near Soldier Summit, and it's used to describe Eocene reddish rocks that lay below the Green River Formation, but above the Flagstaff Formation, both of which are predominantly white lacustrine shales and limestones. The Wasachian age, or earliest Eocene rocks here in Utah are characterized by some really kind of unique fossils, including early primates, rodents, carnivores, early deer, and early horses, which were very tiny. But they're easy to identify if we can locate their fossilized teeth. So today I'm going to try to find some fossils in the Wasatchian Age horizons of the Colton Formation. All right, so let's see what we can find today. Fire about 1 month ago burned this whole valley. This is a superhighway, which I can stop in and think about things. But no, this is the Bonanza Highway, which doesn't get very much traffic. I've been looking at these outcrops right over here, right there, and this ridge here. Gonna go check it out. So we're getting our first up close look at the Colton Formation here, and you can see when you get up to it, it's a mudstone, but it's got these sandstones interbedded in it. Most of these mudstones have this alteration between kind of a whitish or tannish color to a more pinkish or purplish kind of color. So I'm not finding very many fossils. So I'm out here by myself. I need a little bit of help. And I look right over there and I see my team. They're gonna help me find fossils. They've been working really hard out here 24/7, and let's go see if they've collected any fossils, shall we? Here they are. Here's the team. I know, it's ants. Thousands of ants. Look at all those wonderful team players out there actively looking for fossils. So let's see if we can find anything and get some teeth out of this. Now, ants are pretty good at collecting teeny fossils. In fact, here is a piece of rib, it looks like, of a little animal. And a lot of times you find bits and pieces of teeth. They're good at teeth that are around 5 millimeters. And here we go, we're starting to find some teeth. I'll take these back to the lab so we can take a look at them and identify them under the microscope, because they're really small and it'd be difficult for me to show you them on my camera out here in the field. One of the cool things about looking at anthills is you find very tiny little fossils. This is a little fossil vertebrae. So we'll take it back and look at it under the microscope. My old professor at the University of Colorado, Peter Robinson, really perfected collecting mammal teeth off anthills, and spent a lot of time developing different ways in which to collect anthills. And one of the things he also did was kind of a neat experiment where he wanted to figure out how far away the ants are collecting the fossils. because this could affect the stratigraphy if they're bringing them in, say, you know, like 30 or 40 meters away. And so what he did was he laid out a bunch of beads, a small sized beads of different colors at different distances away from the anthill, and went back and looked at the anthill to see how far they were collecting. And most ants only collect within about a meter or two range from their little ant hill. Beyond that, it gets a little too energy intense to bring little grains of sand from much further than about a meter. So these are really nice samples of the fossils that are found in the immediate location. And so that's one of the things that makes anthills really spectacular, is that there's not much stratigraphic mixing with them. All right, so I thought I'd give you the opportunity to try to find a tooth. I have a tooth right here in this section. So give a moment and see if you can find it. Now I have to re-find it. There it is. It's right there. Tiny tooth. Yeah, pretty small. So that's how you find them. So a number of years ago when I was in graduate school, Professor Peter Robinson was working on a project, and basically he had, they were building a pipeline, a natural gas pipeline, or I think it may be an oil pipeline, and they were going to bulldoze this whole section, and there's a bunch of anthills that were producing Eocene fossils. So he went out and he just took shovel folds of in fact he collected the entire anthill, including all the ants, and he put them in garbage bags and brought them back to the lab, and he gave me the job of going through them. And I would basically open up the bag, and I looked in, and there was just tons of angry ants inside the bags. And so he said, just go ahead and wash them. So I just threw them into the wash bin that we had, sprayed them down as best I could. The ants swarmed. They bit me all up my arms, all over my hands. They escaped out of the wash basin that we use, which is a very large wash basin, and they escaped into the lab, and they lived in the lab from then on. And our lab tech person, she was very upset at the ants escaping. So usually when you collect sand off of an anthill, you leave the ants behind. Otherwise, when you are picking through them, you're going to get bit quite a bit, and they're very painful. These are red ants, and so some people can have allergic reactions to them, and they can be quite painful when you're getting bit. So you always have to be very careful of where you sit down when you're looking at anthills for fossils. I think the ants are waking up. And I'm not finding very many teeth of late. I got a little pile of teeth, a few. It's always nice to find more fossils, get a larger sample, but it might be time to head back into the lab and see what types of fossils we did find today. All right, so let's take a look at our little bag of fossils that we brought back from the field underneath our microscope and see what we found. Alright, I apologize for the background noise of my microscope here, but I wanted to show you some of the cool things that we found, and I actually found a lot of stuff while we were out there on those ant hills. Here's some of the things that I picked up. So let's take a look at some of these and see if we can identify them. So a lot of things I found were things like this, which are just little shafts of bone. Very difficult to identify bone shafts like this. Probably mammal, may even be bird, difficult to say. This is actually definitely a mammal. This is a humerus. This is the distal humerus, the upper arm bone here, which is actually really nice, nicely preserved. And then we got some phalange bones. Let's see if I can get some of those in there. I got some actually really good ones over here. That one's a really nice one. These are the finger and toe bones that I found. You can tell it's got the ends here, and these little bumps here would be attachments for the tendons, the flexor tendons. Here's some more toe bones. I found a lot of toe bones today. Here's another one. So one, two, three, four toe bones. So probably not to the same individual. This little thing over here, right here, that's a snail. I found quite a few snails. This thing over here is also a snail, piece of a snail. Wherever it went, it jumped off. Here it goes. Some snails. That's a piece of snail there. Alright, so we got some mammals in here that I've been able to work out, I think, what they are. Let's look at the first one here. This is the incisor, rodent incisor that I found, and you can see this band of enamel going across. Now, rodent incisors are interesting. They're ever-growing teeth that rodents have, and the way they work is that they have this band of enamel on the outside, and so as the rodent chews, it actually sharpens the incisor because that edge becomes always sharpened because the back of it is softer. It's made of cementum or dentine, and it basically wears that down and keeps a nice sharp edge. This is broken on both ends, but this is enough to tell us that it's a nice incisor. This is a tooth that I don't know exactly what it is. It's a very conical tooth. I think it's a premolar. It could belong to the early horse Eohippus. It's kind of big for that. It could also belong to one of the carnivores. There were a number of little carnivores or carnivore morpha, I guess you'd throw them into, that could belong to. Hard to say. But probably one of the premolars. You've got this little cusp here, this tall conical cusp. I'm not quite sure of that one. This is something really cool I found. I thought it was a claw, but looking at it under the microscope, this is a canine, a very sharp canine, and it may belong to one of the primates that lived during this period of time. It's hard to say, but a very sharp little canine. Could also belong to one of the carnivores, small carnivores, but very cool little tooth. I don't think it's reptilian, I think it's mammal. There's no serrations on it, and it has this nice recurve, which is fairly typical of mammal canines. This is something I found that I was kind of super excited when I found it, but it's also sort of sad because this is a jaw, lower jaw. This is the dentary or mandible, and these little holes are the alveoli. These are the where the roots of the teeth would sit. If this thing had teeth, this would be a fantastic find. Looks like it's got would have had the molar, some premolars, maybe an incisor coming out of here. Oh, this looks really cool, and it's actually a beautiful size that is sort of small primate size. So I was very sad to see that there's no teeth in that. But we did find some other teeth that we can identify. So I'm bringing this guy over. This is a very tumbled up lower fourth premolar of a creature called Hyopsidas. And I found another tooth of Hyopsidas. I'll bring that over, which is an upper molar, partial upper molar. And Hyopsidas, I'm glad we found two, because Hyopsidas is a strange little creature, a little small, kind of often described as a weasel-like creature, but didn't have a tail, very long tail. So it's kind of, it actually looked a little bit more like a guinea pig. And it belongs to a group called Condylars. And you may be asking, what is a condylarthran? No one really kind of knows. They've been thrown around the mammalian tree quite a bit. They're probably a group of mammals that are kind of halfway between a sort of a hedgehog sort of group and the parasidactyls and artiodactyl groups are sort of the two sort of places where Hyopsis tends to fall out. Hyopsis was very common in the early Eocene. It's one of the most common fossils you find up in Wyoming in the early Eocene, and extends all the way through the middle of the Eocene, and the second half of the Eocene it disappears. But it also is very abundant early on, very abundant around 47 million years ago, and then it sort of petered out and became extinct. The group, the Condylars, it was the last of the Condylars to have lived. This is that really neat little fossil vertebrae that I found. There's the centrum, neural arch there, where the spinal cord would go through. That's very cool. That's so teeny, very small. This is an interesting tooth. Bring it over. This black tooth. Now this is an interesting tooth. It took me a little while to identify this, because I usually don't find very many of these. I was hoping to find a really nice primate molar like this, but this is actually not a primate. This is Haplomyas. Haplomyas lived during the Wasatchian, and it's interesting because it differs from Hyopsidas, which it kind of looks a little like, but it lacks a hypocone, so it has the single protocone, and it differs from most of the primates in that it doesn't have a cingula or a little groove that or built that goes around the edge of the tooth. And it's broken right here, and it took me a little while to identify, but this is Haplomyas. Haplomyas depends on who you ask what they're related to. I think my personal opinion is that they are related to hedgehogs, kind of in that group of insectivores, Laurasia-therians, though a lot of people have argued that they are more closely related to alpha-therians and are closely related to elephant shrews in Africa. Alright, then I'm going to show you this one, because I was excited that we found something that we could identify. This is a much bigger tooth, and it's just a part of a tooth. When I first saw this, I thought, I won't be able to identify it, but it's actually the posterior part of a lower molar. This is the hypoconylid here, and the way it's arranged is actually pretty diagnostic for Eohippus. So Eohippus, or other people call it Heracotherium. It's also been split out in other names. Usually in these Wasatchian guys, I refer to them as Eohippus, the earliest, or one of the earliest horses, very early small horse, and this is the second part of the tooth. A lot of times you find just fragments of these teeth because they're a little too big for the ants to pick up. And then the last discovery that we found is this. I think it's a lower, maybe second or third premolar, and this one I got kind of excited about because I think this might be a primate. It's got all the shape of a primate. It's very sharp on the edge when these insectivore-like primates. There's a primate called Titonius. It's a little big, but I think it probably, I don't know. It's a little big, but might belong to that. I couldn't find very many good pictures of these lower molars, but might have a little primate here. So that's kind of what we found just in a few anthills in just a few hours.